everyone. I have 12 o'clock my time here in New York, so I think we can dive in and get started. Welcome everyone to Below the Surface, web applications hiding in your web vulnerabilities hiding in your applications. And so if you're here to learn about ColdFusion and web application security, you are definitely in the right place. And so we're going to dive right in. Okay, a little bit about myself. I'm Brian. I'm going to be walking us through this content today. And for about the past 14 or 15 years, most of my experience has been around application security. So working with product teams and working with companies, working with developers to build secure applications and test secure applications and break and then fix secure applications. Before that, I had held a number of other security roles. A lot of my recent experience has been in the financial services and technology sectors, but early on in my career, I spent a lot of time in higher education and working with state and local governments. So definitely there's a large part of my heart that's there. If you are in those sectors, I've been there. I know a lot of the pain and struggles there, and so I'm always happy to chat with you offline and talk about security and talk about building applications and fixing applications and doing all the stuff that goes into that. I will also say that I'm sure that there is a lot deeper and a lot broader ColdFusion experience on the call than what I have myself. Certainly not a ColdFusion expert. By any means, but I will say that I've had exposure to ColdFusion since around 1997 or so, again, in a higher education environment where testing ColdFusion applications and working with users and working with developers to build ColdFusion securely was one of my responsibilities. Okay, so I know it's Friday. I know people are probably already thinking about the weekend, but we're going to dive right in with a quiz. You know what? I'm not sure if Adobe Connect has voting capabilities, but feel free to chime in the chat as we go through these. We're going to be looking at a couple of code snippets, and I want to hear from popular opinion from the crowd. Do we think this is vulnerable? So the first one, we can look here. Looks like we're making a web request with CFHTTP, and we're doing some other stuff with it, printing it out. And so first one, we are vulnerable. And don't worry if you can't spot the vulnerability or don't know why this may be a problem off the bat. We're going to be diving into all of these examples later in the talk. The second one, so it looks like we're doing some kind of file upload, getting a file, checking the MIME type, doing some more stuff with that. Okay, seeing some folks in the chat say yes, it is vulnerable, and yes, this too is in fact vulnerable. Moving on to our third one, it looks like maybe we're grabbing an RSS feed, parsing the content, doing something with that. I'll give folks a second to think about this. Okay, I'm seeing some vulnerables, and yes, this is going to be a security talk. So chances are most, if not all of these examples probably are going to be vulnerable. The third one, okay, so now we're trying to be secure. We're encrypting our data. We have our secret stuff. We're encrypting it, and this is vulnerable as well. On to example number 5. So now we're learning from our mistake. We're not using our secret key now. We're actually encrypting something with our super secret key, and we're passing in some more encryption or in this case decryption options, and we're vulnerable here. And then finally, we have our last example, our hello world. Is this vulnerable? And you know what? We are vulnerable if we're running on ColdFusion 9. And so certainly this is a little bit of a cheap answer, but this is a great reminder insofar as your applications can be secure, your code can be secure, but if your overall platform or your overall environment may have vulnerabilities, those are still going to be things that you want to keep in mind. Okay, so what are we going to talk about today? I have 4 different vulnerability types that we're going to jump into: server-side request forgery, session puzzles, cryptography flaws, and some XML-based attacks. We're going to be focused on uh, ColdFusion, but again, these are all, for the most part, vulnerability classes that will apply to all web application languages, all development environments, and so these are certainly things that you can take back if you're working in other application platforms and look for these types of issues in those applications, even if kind of the code-based vulnerabilities or the functions or the constructs that you need to worry about may be a little bit different. Okay, and then finally, just before we dive in, I'll say from the get-go that these 4 things are definitely a little bit of a mixed bag. These may be things that are relevant in your environment or relevant in your applications, but again, there may be more things from a fundamental standpoint that you want to focus on first. So you certainly want to make sure that your application is covered for things like the OAuth top 10 vulnerabilities. If you haven't kind of measured your application up against those, that may be a good place to start. Certainly, you want to make sure that classes like cross-site scripting and SQL injection, you're kind of aware of. Do these things exist in my application? Have I fixed these? Have I tested for them before maybe you also worry about some of the things that we're going to be talking about today, uh, along with other kind of best practices around authentication and authorization and making sure that your environments are secured, your servers are patched, and you're kind of taking care of all the other security groundwork that are going to be part of making sure that you're running a secure environment. All right, so we're going to dive into server-side request forgery first. So what is it? Maybe you haven't heard of it. What it is a software vulnerability that lets an attacker make arbitrary requests from your application environment. So you can think of it as a situation where basically your application server can get turned into a web browser or a web client that an attacker can control. In most cases, it's going to involve your application uh, taking in user-controlled input that contains a URL or contains some piece of data that's used to create a URL, and then your application makes a request. When we look at what an attacker can do with this, they may be able to do things like access internal hosts, access trusted hosts, because again, they're making that request from your application server. They can turn it around and try and access the server itself, maybe internal services, things that they wouldn't otherwise be able to access. They're able to use server-side request forgery in a lot of cases to leak sensitive information, things like credentials, things like internal components. We're mainly going to be talking about web requests, but this is the type of vulnerability that you may be able to make other protocol requests to. So you can make things like FTP requests with a URL. There have been some innovative attacks where they're using protocols like Gopher and Telnet and mail requests to potentially be able to send data out. And again, server-side request forgery is a vulnerability that in some cases, combined with some other factors or other scenarios, may be able to let an attacker ultimately run commands, run code on your server. So when we're looking at server-side request forgery, there's kind of 2 main types. They matter to a degree, but both are going to be serious. There's going to be fully informed server-side request forgery, where the application is going to actually display the contents of the request being made, And then the other category is going to be blind server-side request forgery, where the application makes the request, but the attacker may not directly get the response back. The things to kind of keep in mind is that, again, even if you find blind server-side request forgery, a lot of times an attacker may be able to use other components or other aspects of your application to maybe get data back. Some cases it really won't matter depending on what you want to do with your attack. Just being able to make that request from your server is going to be good enough. And so regardless, anytime an attacker is able to make that request from your server, it's probably going to be a serious vulnerability that you're going to want to fix. So let's go back to our contrived example, and then this is based on one of our quiz examples. Really simple web application, web page, takes the URL, goes out and fetches this. And when we put it in, the response just prints back the HTML content. Basic example, but kind of really shows how server-side request forgery works, because that request is being made from your application server. So think of what an attacker can access from their home connection or from their mobile device personally, versus if they're in your data center or if they're in your cloud environment, all the other things that they may be able to reach if they start out making those requests directly from your application server. And so that's exactly how this kind of attack could work, or what an attacker could be able to do. So here we have our vulnerable application with a server-side request forgery vulnerability on it. We see our attacker somewhere on the internet making his web request with an SSRF payload with an attack in it. And so from here, he's then able to basically make requests from your server. So he could say, you know what, I'm going to go out and I'm going to connect to random hosts on the internet. I can probe them, I can attack them, I can access what I want. And those requests to those internet sites are going to be sourced from your application server. So when those servers look at where the request's coming from, they're seeing them come from your server, not from him. He may turn around and say, you know what, I'm going to probe the internal network. So I'm going to probe host to see, does this web server have a trust relationship with other sites or other networks, and I can access things now that I can't access directly. And so these could be test servers, these could be demo servers, these could be, again, things that may have a lighter security posture than your public-facing internet servers. And then finally, if your application is running on a cloud service, a lot of the cloud services have metadata services. So basically like internal API endpoints that let you find out things about your cloud environment. You may be able to make changes or get credentials or do other things that are relevant to your cloud environment that, again, the attacker wouldn't be able to connect to unless he was making that request from your application server itself. And so this is why you should care about server-side request forgery. And so let's kind of pull this back to ColdFusion, because a while ago I was looking at some ColdFusion documentation, as one does, and functions like file get mime type caught my attention, because I was looking at, well, what arguments does it take? And I could see that the argument it took could be a file object. So you upload a file and it's going to check that. But I also saw that it could be a path. And so I wondered what would happen if instead of uploading a file for the input, I just passed it a URL. And so by testing it out, passed it a local URL, watch for connections, and I saw, yes, my application did make web requests to that server. And so this showed me that there had to be some ColdFusion tags and functions that were vulnerable to server-side request forgery. So basically anything that took a URL as a valid input. I'd found one, but I really wanted to find them all. And so my approach was to go through and do fuzz testing. So basically do automated testing against all the tags, all the functions, wrote test cases where I was automating and then instrumenting to see which functions, which tags called back. And so I did that, and it's possible that I missed some, but I felt pretty confident that I did a thorough approach. Like I said, kind of ran through the test cases, looked to see which functions did call back, and I found a bunch, a handful of tags where again, some of these may not be a surprise. Obviously, things like CFHTTP, take URLs, some of the file functions may as well. And don't worry, I've links to this content too, so don't feel like you necessarily need to screenshot or write all these down. And then there were a number of functions as well. So some of the ones you may want to care about, we've already mentioned file get MIME type, things like image info and is image file. These are all functions that may expect some uploaded content, so basically an uploaded object, but can also consume a URL. And so these are things to be aware of. You want to be able to find these, and so code review is one way where you can do it. If you're familiar with static analysis, all of these functions can be considered dangerous sinks. So if they consume user control data, these are cases where you want to validate them and either make sure that yes, I'm really consuming only a file object and I'm triggering some kind of error or some kind of failure if I'm being passed a URL as well. On the ColdFusion side, there are some settings in ColdFusion Sandbox where you can do things like, if you want to disable some of those tags or functions, you can do it that way. You can also look to do things like network filtering, both in Sandbox and just on a system or network layer, where your web server may not need to talk to a lot of the public internet, or may not need to even talk to a lot of your internal environment, where you can filter a lot of that out. There's also an Apache VFS, the virtual file system config, within ColdFusion, where you can go in and actually turn off support for various URL schemes, so that things like you can't pass a URL as a file. And so I have a lot of this research documented here. This is a shortcut to a blog post, tiny URL SSRF in CFML, where again, I kind of go through some of this research and talk about the vulnerable tags and vulnerable functions and some of the things that you can do to detect this. Okay, moving on to our next category. This is going to be something called session puzzles. And believe me, some of this is going to seem unbelievable, but these are real examples that I found in real ColdFusion applications. So it's been kind of multi-environment, multi-developer, real applications, and I'm really kind of curious how widespread of an issue this can be in ColdFusion, which is one of the reasons why I like talking about it. So session puzzles happen when an attacker is able to break some kind of security logic or assumptions and put something that is valuable in their session. So their session is probably going to be used to keep their authenticated state. Am I logged in? Am I not logged in? What user am I logged in as? And so that's how a session usually works. And then these session puzzle types of vulnerabilities usually may also involve some other piece of partial authentication or missing authentication. And really the bottom line is that session management is probably one of the most complicated aspects of building an application. You're much better off using something like a vetted session management system. So in ColdFusion, you have CFID you can use, and you can just use ColdFusion sessions, or you can use Java sessions with your JSession ID. Anytime that you try and build your own, there really are going to be a lot of pitfalls. But so let's take a look at a weird example. And this again is based on a real enterprise application that I saw once. And I'd put in username and password, so my victim's username, an invalid password. Login would fail, but then I would look behind the scenes and I could tell that if I did that failed login, but then tried to access a user's profile page, I was able to successfully access that page as that user. So basically, a failed login gave me a session or a partial session as my victim user. And so that was really strange. But I've seen these a couple of different places. The most kind of common places that I've seen them beyond things like that login form. If you maybe have a multi-step login or a multi-step account recovery process where maybe you enter in a username, you answer some security questions, and then set a new password. That step maybe after you've entered in your username, but before you've entered in your security questions. Maybe there's something going on behind the scenes where you're doing a database lookup or putting something in a session to pull out those security questions where something may get stored in the user session. Forgot password is also a pretty common place too, where I've seen these types of vulnerabilities creep in from time to time, where again, you enter in an email address, and then if that's a valid user, that user, their identity gets stored in your session, and maybe something that you can use to make application requests. And so now the downside is, in all of these cases, in all the times where I found these vulnerabilities manually, I never had access to source code, so I was never able to see what the actual code looked like. In kind of looking at these vulnerabilities in other languages and looking at some sample code, the best thing that I can come up with is it may be a situation like this, where let's say during a password reset or during a login, we're maybe doing some kind of lookup on a username. If the username exists, we're storing that username in a session, and then we're kind of going on, and then somewhere else, let's say our profile page, all it's doing is checking for the username in the session variable. If it exists, it assumes we log in, and that may be where the vulnerability or the issue comes in. And so when we look at how can we avoid session puzzles? Again, you want to avoid setting things in the session before the user actually goes through a full authentication. When you look at your code, you want to kind of track and see how do my session variables flow? What am I? What's causing me to write things to the session or change things in the session? And then really on top of that, you want to make sure that every page is actually fully checked for an authenticated session. So if you're using CFAD cookies, you want to make sure that they're actually logged in and not just checking, is this variable set? Is this thing in the session exists? And from a code review perspective, you want to look at all of your code around sessions and around authentication and authorization. And if you have password resets, or if you have a remember me functionality, these are really all of the kinds of things that you want to kind of keep in mind when you're doing your code review. Moving on to our third one, we're going to talk about cryptography, and this is probably the area that I'm most interested in. There's a lot of cool things you need to worry about, a lot of kind of interesting attacks and edge cases. All right, so what do we need to know? Let's kind of go back to our first example, our encryption. And so the issue here is that by default, so if you use the encrypt function in ColdFusion, folks may be aware of this, but the algorithm that you're going to use is CFMX compat. So It's a legacy algorithm. It's great for backwards compatibility. It's great for making sure that applications that were written 10, 15 years ago still work today. But from a security perspective, from a cryptography perspective, it really isn't a secure algorithm. It's definitely better than kind of no encryption at all. But in terms of strong cryptography, there's going to be much better options. And so again, when we look at what our options are in ColdFusion, maybe something like AES, the Advanced Encryption Standard, is going to be a better choice. But here's where it gets a little more complicated, because if you encrypt in AES, you have to do more than just pick AES. You may have to pick, well, what mode is it going to operate in? You may need to pick some things around padding. You may need to pick some other stuff. Obviously, you need to pick a strong key. But by default, if you just say, you know what, let's encrypt this in AES, ColdFusion is going to operate in AES in ECB mode, in electronic codebook. And so how that works is it takes your message, it breaks it up into blocks of plain text, and then each one of those blocks it encrypts one by one with the same key, as we can see here. So a block of plain text comes in, a block of encrypted ciphertext comes out. And so the biggest risk with ECB is that if you have repeating blocks, if you have blocks of plain text that look the same, they're going to output the same blocks of ciphertext. So there's no variation. So repeating plain text means repeating ciphertext. And so with this can kind of introduce some risk. This can aid someone in possibly decrypting parts of your message, or maybe inferring a little bit about your encrypted data. But to illustrate this, let's use a picture. So some folks may have seen this before. This is an example. Here we have just a straight image. This is Tux the Penguin, the Linux logo. And on the right-hand side here, we have Tux encrypted in ECB mode. And so there's enough repeating non-random data in our source, in our plain text, that even though we don't have a full clear image in our ciphertext, we can certainly infer a lot and find out a lot about our original unencrypted image just by looking at what does our ciphertext look like. And so this kind of really shows, if you care about the security of your data, or if someone decrypting some of it is something you need to worry about, ECB mode probably isn't the best choice that you have. So what else do we have? We can maybe choose AES and CBC mode. And so right off the bat, this looks more complicated. So we have more lines. We can see that as we encrypt our data, we're taking some data from the previous block and using it as we encrypt the next one and the next one. And the same thing when we decrypt, we're using some output from our previous decryption as we decrypt the next block and the next block. But now let's go back to this example. And so here we're decrypting something. We're using our super secret key, which we know is going to be ultra secure. And we can see we're operating AES in CBC mode. But remember, we also said this example was vulnerable. So this is where things are going to get interesting. What if I told you we can break AES CBC without any math? It's a Friday, no one's going to want to do math, and we're going to be able to break CBC mode. And when I say we're going to break it without math, I also don't mean that we're going to break it by hitting someone with a $5 wrench over and over again until they give us the password. The way we're going to do this is we're going to carry out something called padding oracle attack. And when I say oracle, this has nothing to do with a software company in Redwood, California. This has nothing to do with databases. Oracle just refers to being able to divine some type of secret or valuable information. Think Oracle at Delphi, not Oracle databases. And so the biggest thing to keep in mind with this type of attack is that even ciphertext, if a user can control it, is still untrusted input. So I know we know uploaded files are bad and user input is bad, but even if that data is encrypted, if it's something that a user can control, it can still lead to security issues. And so the bottom line is, if you're operating in AES CBC mode and don't validate the integrity of user controlled data, so basically if you're not using something like a signature or an HMAC, your application is probably going to be vulnerable to a padding Oracle attack. And so we're not attacking the actual encryption, we're not cracking a key, we're not doing any complex math. What we're doing is we're carrying out a side channel attack where we're getting feedback on the decryption process, where we can basically infer what our plaintext is, and then we can actually carry this out in a way where we can not only decrypt arbitrary values, but we can also create new blocks of ciphertext and add this on. And so again, no knowledge of the key is needed. We're not breaking the encryption. We're not cracking your key, but it's an interesting attack nonetheless. And so before we talk about how the attack works, let's just kind of talk about padding for a minute. Lots of block ciphers are going to need message padding, and maybe when you've set up code to do this, you've seen things like PKCS5 or PKCS7. These are just padding schemes. And so what padding does is it's going to let us encrypt messages of any size. So it's going to make sure that our plain text, the message we want to encrypt, is an exact multiple of the block size that we need. So in this example here, we want to encrypt the message, the password is swordfish. And so here we're going to need 7 bytes of padding. And so for the last block of our message, our last 7 bytes are just going to be hexadecimal 7777. So basically 7 bytes, each with a value of 7. And so that's what padding is going to look like. If you're a developer, all this is going to happen behind the scenes. This is built into the encryption and decryption libraries. The most you may need to do is pick a padding scheme. But then when we're actually going to decrypt, how does this padding get checked? Well, there's a couple of ways, but the most common scheme is we're going to decrypt a message, and then before the decryption algorithm says things are all good, it checks the padding. It will read the final byte of the plaintext. So we're going to read the last byte. We're going to call that byte n. If n is bigger than the total size of our block, it's going to say, you know what, this isn't right, throw an error. Assuming that checks out, we're then going to go through n-1 bytes. So in this case, our last byte is 7. We're going to then read 6 more bytes. If any of those other 6 bytes don't contain the value we're expecting, so 7, in this case, we're going to throw an error. And then assuming that checks out and we're good too, it's just going to then chop off the last n bytes. So chop off those 7 bytes of padding, say, okay, we're good, decryption's been successful, and then move on from there. But the thing to keep in mind is that all we're doing is decryption. So there's no guarantee. We could be decrypting garbage data. It could cause errors later in our program flow. We could be expecting alphanumeric text, but our decrypted image or our decrypted data is a picture of a dog, and it's going to cause application errors. And so what do these errors look like? So this is an example of a verbose padding error in ColdFusion. So if we tried to decrypt something and the padding was wrong, we would get an error like this. But for a padding Oracle attack to be possible, all we need is some kind of variation between yes, everything's fine and everything's decrypted well, or no, there was some kind of padding error. And so variations, even if it's a cleanly handled exception, if there's some variation, let's say uh, the text of exception 1 versus exception 2, or even something as trivial as the white space being a little bit different. Those kinds of variations could be something that you can key upon and instrument upon to say, yes, encryption worked fine, versus no, encryption failed because we had a padding error. And so this is how it's going to work. And don't worry, this is a little bit complicated, but I have a demo on the next slide, which should also make it a little clearer too. So on the left-hand side here, this is what we want to do. We want to decrypt our ciphertext C2. And so normally this would flow through. We'd have our key, get to our intermediate state where we're XORing. That's the little circle with the plus against our previous block of ciphertext, and then we get down to our P2. But the way the padding oracle attack works out, if we now look on the picture on the right-hand side, since our ciphertext is user control data, since it's something that the user can control, we're going to basically make guesses, and we're going to find some ciphertext, so some C1 prime, where our plain text works out to be 1 byte of padding, so 0, 1. And so we can go through here and basically we guess for all those values of the last byte of C1 prime. So we're guessing byte by byte, and maximum we may have to make 256 guesses, but we should get 255 padding errors, and then one case where we may get some other type of error, but we don't get a padding error. And then that way we know, well, we have our block of chosen ciphertext. We know the last byte of the plain text is going to be 01 because that's our padding. And then what that lets us solve for is the last byte of I2, of that intermediate state. And the thing to keep in mind is that I2, our block of intermediate data, is the same on the left as it is for the right, because then we can take that byte of I2, and so we have our ciphertext, we have something that we're going to try and decrypt, our real C2, we and then we can basically just XOR our ciphertext against our I2 value, and then we've just decrypted 1 byte of the real plain text. And so simply that's how a padding oracle attack works. We can automate this and basically go byte by byte, guess by guess, and decrypt something that's been encrypted with AES CBC mode if we're not validating the ciphertext before we're trying to decrypt it. But let's look at a more real world example. And so our vulnerable code had this work with cookies. In this example, instead of cookies, we're passing in a big long encrypted string through a URL. And we can see, well, okay, this is going to decrypt, and we have our username and our role printed out. But again, our secret is some big long hex string of some data that we want to figure out what's in there. We may want to try and overwrite some of those values, but we don't know anything about the key or anything else. And so as we run through what our padding oracle attack looks like, we are now running an automated program that is guessing against our application. And this is one of the few times that hacking in real life may look a little bit like hacking in the movies, because as we go through, as we're making our guesses, we literally are inferring and figuring out the plain text byte by byte, block by block, as we decrypt that out. And we can see all of our data coming out. So we see our email address here and our user ID and our username and our user role here. And then finally, as we've decrypted everything, so we see our full string here. And then using a similar process, we could even go in and potentially change these values or add on more data. So we could, for example, we may be able to change our username in here or change our role so that our application would decrypt this and say, well, hey, your username is now admin and your role is now admin versus what's actually in our original piece of ciphertext. And this again is carried out through the padding oracle attack. When we look at avoiding cryptography flaws, bottom line, we want to make sure we're using secure algorithms working in secure modes of operation. Biggest thing again to take away is even if it's encrypted, user control data is still untrusted and can still lead to vulnerabilities. When you decrypt anything that the user can control, you really want to do some type of integrity checking. So add an HMAC, add a signature, and then check that. And if that check fails, then just stop. Don't even try and decrypt it. Just say, you know what, triggered an error, and then the data is no good. From a defense or a detection perspective, some of these attacks may be noisy. Again, we're making potentially 100, 200 guesses per byte. So on your application side, you may see a spike of 500 errors, or you may see a spike of encrypted related errors. Where if you're watching for those things, if your detection is instrumented to look for those things, those can be indicators for someone maybe trying to carry out a padding oracle attack. And then finally, I'll also mention that there may be times where encryption really isn't even what you want. So for things like user passwords, for example, you almost never want to actually two-way encrypt encrypted passwords. Something like using a secure one-way hash is going to be the way to go. So in some cases, forget even the correct way to encrypt. You may want to take an entirely different way to secure some of your sensitive information. In terms of code review, obviously functions like encrypt and encrypt binary and decrypt binary, you want to go through and see, well, hey, are we consuming user-controlled ciphertext? And then beyond that, are we using secure algorithms in secure modes of operation? Okay, finally, we're moving on to the last section here, XML attacks. And so why this matters is that XML really can live in a lot of places, and these may be places that are significant to your application. So some of these are obvious. XML files obviously contain XML, but there may be things like other file formats that don't have an XML extension that really under the hood contain XML data. We looked at things like RSS feeds that can contain XML data, REST APIs. Even though JSON is becoming the more popular data format, there's still plenty of REST APIs that send and receive XML. The same things for things like SAML and SOAP messages. And then also possibly a little less known things like your current Microsoft Office formats. So your DocX and your XLSX and your PPTX. Those, when you look under the hood, contain a lot of XML data. And then finally, there can be a lot of file formats. So even things like PDFs and a lot of image formats, even though the data itself or the kind of core data isn't XML formatted, those file formats can have internal fields or metadata fields that can contain XML. So if your application reads those files or parses those files, or you're using third-party packages that process those files, you at least need to be aware of these are all the places where XML data can lurk. And when we talk about XML, the biggest vulnerability that we need to be aware of is something called an XML external entity attack. And so this is going to occur when a vulnerable XML parser processes malicious or bad XML content. Your application doesn't need to spit out the results of the processing. And then kind of similar to when we talked about server-side request forgery, a lot of times we can turn around and use these vulnerabilities to read files, connect to internal resources, and then possibly do more. So here we have what a sample XXC payload could look like. Here we're setting up an external entity that points to the etc password file. And then if this was to be rendered by a vulnerable XML parser, in that product ID value, instead of having that ampersand XXC, we would have the actual contents of the password file. And then also when we're talking about XML and XML functions, there's definitely other threats and other risks and attack vectors you need to worry about. Things like XPath injection and XML style sheet, XLST injection. But for right now, XXC is what we're going to talk about most. But these are also things that you're going to want to keep in mind. So let's go back to our earlier example from our pop quiz. So here we're pulling in an RSS feed and then passing that into XML parse. The risk here is that as it is right now, if that RSS feed contains an external entity, that entity is going to be expanded and rendered when that XML document gets processed. And so like our previous example, here the title of our RSS item is going to be the contents of our password file. I also mentioned Word documents. So docx file, if you were to rename it to .zip, it's basically just a zip file that contains a bunch of files and folders, and pretty much all of the files are XML files. And so there have been vulnerabilities in the past, and I think today most of these have been, or really all of these have been sorted in ColdFusion, but there have been components that process Office files where if you were to go in, modify one of these XML files inside of the docx file with an XXC payload, that would get fired, that would get rendered when your document gets processed. Okay, so how do we fix this? Well, the good news is that as of the latest Adobe Product Security Bulletin 2244 back in October, all of the native ColdFusion functions now do have an XML parser option to prevent XXC. The downside is that you do need to pass that parser option in each XML function call. And so if we were looking to secure our code, here we can see we're setting up our parser options and setting allow external entities to false. And so this is something that you could obviously set globally in an application CFC or somewhere else like that. But then every time you made one of those XML function calls, so every time you made an XML parse call or an XML transform call, you'd have to make sure that you pass that parser option in there if you in fact did want to turn off external entities. So that's definitely good news. This is an improvement. Some of these were fixed previously. Now all of the functions are fixed, and so all of this is possible too. Okay. Also in Lucy, there's similar settings. You can drop these XML features into your application CFC, and then automatically all of your XML functions, all of the native XML functions should have external entities turned off by default. So in Lucy, there's no parser options that you manually have to pass. It's just set this and you should be good. And then obviously, if you have anything that isn't a native XML function that's processing XML, so third-party software, third-party libraries, you're certainly going to want to test and confirm whether or not those are vulnerable or whether or not those are securely configured. And yeah, this is some legacy information, and these are some older vulnerabilities. I think this this CVE from 2016 is when some of the docx and XLS stuff got fixed in ColdFusion. Apache POI is one of the core libraries for Java libraries for processing Word documents, and so there were some more security fixes back in 2019 that have trickled down into ColdFusion. But again, it's going to be important if you have third-party stuff that is interacting with XML. You're going to want to test that and make sure that that actually is secure. So again, kind of same thing, and we're definitely starting to see a pattern here that we care about user input. Just in this case, if our user input is XML content or XPath arguments or style sheets for XML, we want to validate them. We want to make sure that our XML components are secure. And again, all the parts of your application that may interact with XML or consume XML are going to be areas that you want to do some further security review and security testing. So obviously is XML and XML parse and XML search, and pretty much if the function name starts with XML, it's probably going to consume XML and is going to be an area that you want to look at. Okay. As we start to wind down, and I alluded to this in our XML slide, we really do see an underlying cause for all four of the vulnerability classes that we talked about today, and that was user input. And so user input is going to be anything that the user can control, and this black garbage bag is a perfect example because you don't know what's in it unless you look inside. Is it full of candy? Is it full of garbage? Is it full of whatever? Unless you check, you have no idea what's in there. And so the tricky part is making sure that you're aware of and looking at all the different areas that a user can control. So certainly any variable passed in from a URL parameter or an upload form, things like cookies are all able to be controlled by the user as well. Variables within the CGI scope, again, some of these can be controlled via the user in things like request headers or other parameters. As we saw, there may be some cases where the user can control things in the session. Maybe they can, maybe they can't. And then finally, if you're creating secondary values or secondary variables from any of those user controlled sources, those are really just all sources that you want to kind of trace down and see, well, how does this user controlled data flow? Where does it go? And really just bottom line is you want to validate all user input for all of our dangerous tags and functions. So whether it's XML parsing, whether it's for our web requests that can lead to server-side request forgery, whether it's encrypting and decrypting, anytime you're receiving something from a user, you really do want to validate, is this the format and length and style and content that I'm expecting? And if not, I probably either want to return an error or do some kind of validation or do something else where I'm not setting myself up for security issues down the line. Yeah, beyond that, so obviously there are certainly more things to worry about than just these four things when you're securing your application. Things like the OAuth top 10, input validation in general, our authentication, our authorization, looking for business logic flaws are kind of all parts of things that we want to keep in mind. Security patches are important too. You want to keep up to date on your application server patches, on your underlying OS patches. To throw in one shameless plug for something that was fixed in Adobe Security Bulletin 2175, there was a bypass for cfadmin that I found and reported to Adobe. At last look, there were still a fair number of vulnerable systems out on the internet. So this is definitely worth something to making sure that you have applied this, that your cfadmin is locked down. There was another critical Lucy vulnerability, not found by me, found by other folks about 2 years ago. This again is some Lucy admin vulnerabilities, and this is certainly a really important one to make sure that all your servers, internal, external, development, test, everywhere has been patched. Kind of on that same token, you want to make sure that you're locking down your admin interfaces, so untrusted users and internet users shouldn't be able to hit your ColdFusion admin and your Lucy admin and your internal customized admin interfaces that should be protected. Beyond that, there's also lots of really good security guides out there. The Adobe ColdFusion lockdown guide and the similar one for Lucy gives you great out-of-the-box things to do to make sure that your environments are secured and locked down. Finally, here's my contact info, my email address. Like I said, I love talking about this stuff. Feel free to drop me a line and I'm happy to chat. I tweet very infrequently at Hoya Haxa. Pretty much all of my tweet and contents is going to be about security. A large amount of it is also ColdFusion related too. And I blog, again, pretty infrequently at hoyahaxa.blogspot.com. The things that I talked about, server side request forgery and your vulnerable tags and functions. Some of the XML stuff and the XML secure configurations are all linked in blog articles. And yeah, that's what I have for today. Thank you very much. I see a couple of questions. I am happy to go through them now for as long as we have time. And thank you very much, everyone.